I've lost my mind doing this game, yeah. Like Vincent van Gogh. He dedicated his life to his art and lost his mind in the process. That's happened to me.
So this is our following solution that we have over here. So to give a rundown and breakdown of our time and space complexity for our following solution is, given the fact that we have a series of rows and columns and we're keeping track of everything that has already been visited to start, making a series of Boolean conditions, our time complexity is going to be relative to the number of rows and columns accordingly. So therefore our time complexity is going to be O of m times n. However, the good news is we're not using a data structure to store anything that has already been tracked. We are only scanning through the rest of the matrix. So therefore, our space complexity is going to be very efficient for this, which is going to be O of 1, which will therefore be linear and not constant, since we're not using any extra space to be able to store anything that we have already set in place. And people can solve this problem with a map or a set accordingly to store everything. However, within the efficiency of our space complexity, this is why we're just scanning throughout the rest of the array to be able to have a set solution. All right, so this was set matrix zeros. Thanks again for taking time to watch this. If you enjoyed this, feel free to like and subscribe. And if you have any comments, feel free to put them in the comment section. As always, take care. Cheers. Bye-bye. Okay, and submit. Woohoo, we got this. So to be able to expand upon the relationship of the space and time complexity. So our time complexity, given the fact that we are dealing with a matrix to even start with, and we are storing our following matrix within a list, the time complexity for the following is going to be constant, but instead it's relative to the rows and the columns. So therefore it's going to be O of m times n, where m is the number of rows and n is the number of columns. That's because every element in the matrix is visited once, and the space complexity is also the same, O of m times n, where m is the number of rows and n is the number of columns, because we are storing each of the elements of the matrix in a list to start with. So yeah, and the following solution is already further optimized since each element in the matrix is visited exactly once. And yeah, this was a spiral matrix. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comments section. And as always, take care. Cheers. Bye-bye. And Leetcode is down. That's kind of cool. Yeah, that's absolutely great. This entire website is completely down. So anyway, just to be able to go over the space and time complexity for our following solution, I'm also going to have it up here and be able to edit it, is that given the fact that we have two nested for loops accordingly, the time complexity for this is going to be O(n) squared, where n is the number of rows relative to the matrix, since we're also scanning both two elements accordingly. And then we're going to have a space complexity, luckily, since we are not using any data structure to store anything. The space complexity is going to be O of 1 to start with, since we're not storing anything and we are asked to be able to rotate the matrix as is. So yeah, this was Rotate an Image. Thanks again for taking time to watch this. If you enjoyed this, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. As always, take care. Cheers. Okay, so now just to be able to give a rundown and breakdown of our space and time complexity for the following solution that we have over here, is that the time complexity for the following solution is going to be O of n times 4 to the 4 to the L, where n is the total number of cells in the input board, and L is the length of the word to be matched. And for a cell with one letter, the total time complexity would be O4 of L, given the fact that we are dealing with a matrix, and that's in the case of the worst case scenario. But since we're also doing this recursively, the depth first search would be performed to the depth of the length of the matrix, the word, and we would have 4 different directions to explore relative to finding said word. So 4 represents the 1, the length of the given word, and then n also represents the total number of cells in the board that we have. And meanwhile, the space complexity that we have for the following is going to be O of L, where L represents the length of the word that needs to be matched inside of our given array. Since 1, it will be constant, given the fact that 1, we are using a data structure, namely we're using an algorithm really in this case for depth first search, which utilizes a stack to be able to keep track of every single element that we have visited, so therefore it will be constant, and L represents the length of the word, so the space complexity would be O of L. So yes, this was word search. Thanks again for taking time to watch this. If you found this helpful, like and subscribe, and if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.